Good morning, Tahmina Khan is here in TKMaths S1. In today's video, I will show you the solution of February-March paper 2024 of Mechanics M1, which is which is paper 4.2, and code is 9709 as it is written on the screen. So as there are 7 questions in the paper, so what I'm doing, I will show you the solution and main point I may discuss. Otherwise, I'll just stop on the screen. You can go through the working. Where you have confusion, you can write down your comment and I'll explain that to you. Furthermore, there are few challenging questions. I have made video of those separately and explained it in detail, and the link is given below in the description. So to see the explanation of those questions, you can refer the description. Otherwise, you can understand the working yourself. So I'll stop on every working 15 to 20 seconds. Main point I may highlight, and then you will take a snapshot or try to do it yourself. So let's start with question 1. So this question is related to this distance time graph. Along the working, I have explained or written in detail also, so that you can understand. I'm decreasing the size so that you can look at the solution. Because this was a straightforward question, so I'm not explaining that one in detail. Part B, where students mostly make mistake, it's a conversion of the speed time graph into a velocity time graph. Here I would like to explain one thing. When the line is like this on the distance time graph, it means it is a constant velocity, right? Because gradient is same, so that's why lines are horizontal here. And when it is like this, gradient is negative, it means it is negative velocity, and that's why we have drawn the line here. The gradient was minus 3.5 for this aspect. Now this is question number 2. You can read. I have solved it by 2 methods. First method is by dividing the journey into 2 parts. The part when it is going up and the part when it is coming down, and then adding up. This is first method. Here I have mentioned all the values which were given in the question. And what I have done here, because the question told you that the complete journey for 2 seconds was, and at this point it was 5 meters per second after 2 seconds of the journey. So what I have done, I have found out this time when it was coming down with the help of this information, and then I have minus it from the total journey. So I know the time it took to go from starting point to the maximum point. So I have kept that approach, and from here I have found the starting point velocity, the projection velocity at the time of projection, projected upward. Second method. In second method, irrespective of the way of journey, we just take all the directions at different points. So I have drawn here arrows, and then I have applied them in the constant acceleration formula, and I got the starting point velocity, projected velocity from here directly. So you don't need to break up into 2 steps, the whole traveling time or the motion time of the particle. This question mostly is misunderstood. According to this question, when the time was above the speed of 10 meters per second, the distance traveled. So I have mentioned here in purple. Okay, this is the distance we have to find out. And you must know this thing, that from any particular point, the time the particle takes to go up, the same time it takes to come down, right? Law of physics. So when we have said here 5 meter, it means the time it took to go from here to here. So definitely it will take the same time to come from down. Okay. Now, like in the previous part, I have solved the question in the second method, by the second method. So I have done here a little bit of working, because this happens in the classroom. Students get stuck here and ask. So I am leaving this to you, okay, why this is not workable, and you can give the reason in the comments, or you can ask it over there. Question number 3. It's very important that you sketch the situation, then it will be very easy for you. So here I have written what is power, how to change this into force equation, what is given to you, so you can see here. And when I'm writing forward force minus backward force, whenever you apply Newton's law, our target is to find out the resultant force, and that is only possible if you minus the effect of two forces, all which are acting in the forward direction in which the motion is happening, and minus all the backward forces which are acting on it. And here the forward force we have taken out from the power divided by velocity because of the given information. And whenever body is in motion, it is experiencing a maximum frictional force, and that's why I have written mu r. Mu r is the formula for the maximum frictional force, right? And I hope you understand how do we get 600 sine 30 and 6000 cos 30. You know this thing. Otherwise, I think I have explained in the next question. This was again considered an easy question. Forces are in equilibrium, so all the forces acting horizontally in the opposite direction are equal to each other, and all the forces acting vertically in the opposite direction are balancing each other. And exactly the same I have done here, and then solve them simultaneously. So you have to resolve all the forces horizontally and vertically. It will help you to solve it. After that, you can use calculator to get the answer. You have to find out theta and force. This question was taken from the calculus, the topic calculus. Velocity equation is given, and I have written here what you have to recall. When we differentiate velocity, we get acceleration. When we differentiate displacement, you get velocity. So I've written here, and integration is the reverse. So here the question was talking about distance. So we have done what? We have integrated it. And I have written here few things which I want you to think about. Why did I do this? Let's see. You can make connection. Otherwise, I would appreciate if you can write the comment to find it out. And if you understood, then it is very good. So basic integration with the limits 0 to half. And second method, sometimes the student actually find out the displacement equation and then substitute the value. So I have done that also in case if somebody wants to do by that method. But of course, it will be time consuming and is not preferable. Rather, first method is more preferable. Answer will come same. How do you know this condition? By the way, it was not given straight away in the question. So the technique is, you read the question. If you see the first line where it is saying a particle moves in a straight line starting from point O, right? So we are timing it from there only. Part B of it. Now part B is a tricky part. So you will see the explanation of this question in detail in the description given below. Question 5, 6, 7 I have explained in detail. So there are hidden, I would say, hints in the question. The sketching I have done just to explain to you, that's why I have said recall. Otherwise you don't need sketching here. If I have written here this is incorrect, the only reason is you take it in one go if the area is either totally above the x-axis and you're taking the limit, for example 0 to 3, or if it is totally below, then it's fine. But when it is in parts, like half of the part is above and half of the part is below, and you can see the area is also not same, which will give you distance, so you do it in steps and then you add up. It cannot be done in one go. Okay, so I have done integration here because the first part was saying integration 0 to half, so second part will be from half to 3, the limits that you can see from here, but sketching you don't know. So from where are you getting hint? From here, right? I'm repeating, if you need explanation, see the video which I've explained in detail, and the link is given below. Plus and minus sign, why I'm ignoring, I hope you understood, else you can write down in the comments. Just to save time, I'm making it like this so that people who are interested to see the solution can refer it directly. Like I said, in this paper, question 5, 6 and 7 were little thought-provoking, where one has to focus more. It is always a good idea, whenever you see a question, write down all the important information, values, everything in the side, on the right hand side in the column or in the diagram, so that you don't have to read the question again and you can miss out few information or misread some information. So it's better to jot it down separately and then start substituting it. And like this questions at times bound you that you have to use only energy method and you cannot use constant acceleration formula over there to solve it. So this is the same case, and in these cases when we use energy equation like I have done here, you can see what I have written: mechanical energy plus minus work done. Why did I write plus minus work done? Because if work is done by the engine force, it means you are adding energy into it. But if it is done against overcoming the friction, then it means energy is taken out. So that's why we do minus or plus accordingly. You can see here I have described in detail for this particular situation. And mechanical energy, I have told you here to recall, it is sum of kinetic energy and potential energy. Further explanation, you can see the link below. And then it is this was actually a another challenge question, need a lot of thoughts. So all the important points which I have highlighted, I have mentioned in the diagram below. Here it is. And this my FF and BF is basically forward force and backward force, which I have just explained to you. Anything you don't understand at any point, please write down in the comment. I would love to explain it to you. By the way, there is a I would say misunderstanding can happen that somebody may consider that particle when reaches B, it took 0.5 second, and one has to prove that the speed was 3 meter per second. If you will see my working, I have tried to prove both the point that the velocity was 3 meter per second and the time was 0.5 second. So I'm not assuming here that one thing is given and you have to find out. So I have found out both the things here. This is my understanding that this is the expectation from the student in this question. Like you see on the right hand side, I have written down all the information which is given to us in the question. Cos theta was not given and we need to find it out. So I'm using the concept of trigonometry. I hope you know that. Some people find out theta from here and use that. That is also fine. But then you need to be, what it is called, write more decimal places so that the final answer is not affected when you're writing in 3 significant figure. I've tried to sketch for every question and explain the situation, and I've written descriptions also so that you can understand the working I have done here. And if I'm writing here, do not make mistake of taking 6, because in part 1, where it is here, in part 1 we had to verify the speed 3, so we found out the acceleration. Now this is a smooth surface, this is a rough surface. So when particle P reaches at this point and then onward it is on the rough surface, then definitely the acceleration will not be the same. It will be the same acceleration which Q is experiencing, because Q is going from here onward on the rough surface. So that was the miss or the trick. So one has to be careful about it. Okay, so this is the last part. And when I'm writing MP is equals to MQ equals to M, because the mass is same, so if these two M are same, then I can factorize it, and that is the reason I have broken it up into 2 parts here further. And momentum, you know, is mass into velocity, right? And because of the law of conservation of linear momentum, we consider that energy is not wasted, and the momentum before the collision and after the collision of the system remains same. So that's why we keep it like this. So okay, just a few seconds here. You can go through it, then I'll scroll it up. So with this, the video will end, and thank you very much for watching. You can write any question in the description below. If any point is not clear, mention the time at which the query is, so that it is easy to refer back to the video. And the last thing is, again I'm repeating, the question 5, 6 and 7 I have explained in detail, and the link is given below. Thank you very much. Please press like and subscribe button and share it with your friends. Take care. Allah Hafiz. So now we will see question number 7, which is the last question. And if you want to see the explanation of it, you can see the link in the description below. Here I'm showing you the solved solution, just the working. I have tried to highlight all the important things on the diagram which you all are supposed to draw when you're solving such questions. So part B is find the time that it takes from the instant the two particles are released until they collide, right? So this is the working I have done here. This forward force and backward force I have already explained. Just substituting the values. And if sine theta is given to you, you can easily calculate cos theta with the help of this sketch and the Pythagoras theorem. So then you can see here I would like to say one thing. It should be t plus 0.5 square. I have taken this value into consideration here, but it's better to write it here as well, because you're taking this time as t second. So what will be the rhyme for q? That is the purpose behind. For more explanation, you can look at the link in the description below. So I'm simply equating the two distances equations I have found for P and Q and finding out the time t. Now this time t is for basically particle P. If you have to find out for particle Q, you will add in it. Why? Because the particle Q took time ½ second to come from here to here. And then this is the last part of the question. And this question was a challenging question, by the way. So you can see here I've written the description also. I've explained very much in detail in the video I've made especially on this question. Link is given in the below description. You can put the video on pause and try to solve the question yourself. And this is the end. So you got time 0.25 seconds. So I hope you understood. Thank you very much for watching the video. Please press like and subscribe button and share it with your friends. Take care. Allah Hafiz.